Konbanwa. We made it. It's the last talk of the day. We can do this. My name is Tom Enebo. I'm from the United States. I live in the state of Minnesota. I live about as far away from the ocean as is possible. I co-lead the JRuby project, and I've been working at Red Hat for the last 4 years, working on JRuby as my full-time job. I've actually been working on JRuby full-time for 10 years, working at Sun Microsystems and Engine Yard also. It seems like I actually just learned Ruby yesterday. I remember still getting Dave Thomas's Pickaxe book and really getting into it. I've been using Java for more than 20 years. It actually feels like 60 years. It's a joke, Jodan. And I like craft beer, so if anyone knows of any good craft beer places in Kyoto or Tokyo, let me know. This is not me. I love it though whenever it's displayed because people always walk up to me and say, "You don't look very much like your profile picture." So for the few people that might not know what JRuby is, I had to throw this slide in. JRuby is just a Ruby implementation that happens to be implemented on the Java platform. We have two major versions, JRuby 1.7, which supports either CRuby 1.8 or CRuby 1.9 modes. And you can enable that by passing in a command line option. It will be supported only to the end of the year. But the version of JRuby I'm going to talk about today is JRuby 9000, which is just tracking the latest version of CRuby. Although I think right now it's just 2.3.1 for us at the moment. It's distributed under 3 different open source licenses. You just pick which one you want to distribute JRuby under. Most people tend to pick Eclipse Public License as being the most permissive. And I'm not going to talk about this today, but JRuby interacts really well with the Java ecosystem. So it's very easy to talk to Java types from a Ruby syntax, so you can go and pull in a Java library and interact with it. You can go and talk to other JVM languages that are implemented on top of it. We also have native threads, so we have a bunch of bonus features on top of just being a Ruby implementation. So today I'm going to go and talk about JRuby 9000. And it's sort of a retrospective where we discuss the good things that happened and why we like JRuby 9000. But then I'm also going to go and talk about some of the challenges that we ran into and how we try to address them. Okay. Sorry. So the major bullet points for JRuby 9000 was that we planned on only following the latest current release of CRuby. We wanted to make sure that we could clean up some APIs. It had been about 7 years since the last time we had a major release. We decided that we were going to bypass Java's I/O APIs completely and just call into C because we wanted to have better compatibility. And we completely changed our runtime since 1.7. So I'll go over each of these in turn. Following the latest Ruby has been great, and I'll show you an example of why. Here's some example Java code in JRuby 1.7. I'm showing you the implementation of the spaceship operator in Ruby string. You can see this JRuby method annotation at the top. Forget that. This is how we go and bind Ruby methods to the Java implementation. And you can see here that we have one implementation for Ruby 1.8 and one implementation for Ruby 1.9. And in fact, these methods are virtually identical. The semantic differences between versions of Ruby are usually pretty small. But over the years, on rare occasions, we would go and accidentally used the wrong version of a method for the wrong version of a method. And for the most part, a method like the spaceship operator, we wouldn't notice any problem for a while because most people are using 7-bit ASCII strings, and the semantics are pretty much the same between 1.8 and 1.9 as long as you're just using ASCII. But then once you start using multi-byte characters, we start getting really weird results. So someone would report it and we'd fix it. But it was painful having to make sure that you called the right version of a method. So in 9000, we were able to remove quite a bit of Java code, about 10%. Because we're not supporting multiple versions, we also are able to get rid of half of our Ruby code. And I just talked about the confusion before. Breaking APIs didn't turn out as well as we had thought. I don't actually know if that's a sad panda or not, so I had to add a teardrop. So when we first started working on JRuby 9000, we deleted the methods that had 1.9 on the end because it would be a lot cleaner API just to say op plus instead of op plus 1.9. But a few people that were using Java native extensions, Java native extensions are similar to C extensions and MRI, but they just allow you to call into Java. They're made for the same reasons as C extensions and JRuby. But people writing native extensions noticed that we removed these methods. And then we were like, just use op plus. But then they came back and said, we want to support JRuby 1.7 and JRuby 9000. And then we thought, we didn't do any planning. This was kind of dumb. So we added back those methods, and you can see here that we only have one implementation now, but we have 2 entry points into that one implementation. So we have a plan, and JRuby 50,000, which that's a joke. It's not going to be JRuby 50,000, or is it? JRuby 9000 started out as a joke, and then it became a release. So I'm just throwing this out here. So we're going to expand our embedding API. So for example, for constructing core types, we'll have a series of methods that allow you to create a new string. These will be statically importable, so you can just load the creation methods you want in your extension. This will be a lot more similar to how C extensions look, at least. Anything that has a JRuby method annotation, we're going to allow you to call that from Java. Native extension authors want to call the Java implementation, but they don't want to do a dynamic dispatch. So this allows them to do a Java dispatch and have a faster extension. Sometimes you get back some objects, and there's some very convenient methods that you want to call on those objects. So for those methods, we're adding an extension annotation so that people can call those without having to indirect it through some other embedding API. It'll look a lot cleaner. And second to the last, we're going to create a tool where you can go and take your source code and put it through the tool, and it'll lint the code and tell you whether you're using only endorsed APIs or whether you need to go and change some stuff or maybe open an issue. And I didn't put this bullet point, which tells you that I write a lot of software. We're going to make documentation, so people know what they can use and not. And we obviously have to set this up at least a year in advance so that people can go and update all their native extensions for JRuby 9000 so that when JRuby 50,000 comes out, it'll work on both releases. So we have a plan. We decided to bypass Java I/O APIs and go straight to C. The main reason for that was that we wanted to have good compatibility with JRuby, and the Java I/O APIs just didn't provide enough for that. So far we have good performance, good enough where we haven't bothered to try tuning this yet. A performance problem came up last week and we were looking at it and we realized that we're doing some extra copy, so maybe we can get a little more performance yet, but it's been pretty good. Except for Windows, we didn't port Windows to use C code yet, so it falls back onto pure Java mode. We still support a pure Java mode for restricted environments, so if you run JRuby on Google App Engine, you can't call out to C, and so when we actually run on Windows, we just fall into that code path and use pure Java. So Windows is just some work that we need to do. There's no limitation, so hopefully we'll do that pretty soon. And I just wanted to put a special note that for a pure Java mode, over time, it keeps getting more and more compatible with JRuby, but it goes on the time schedule of releasing Java. So hopefully when Java 9 comes out, we'll get a little more compatible in pure Java mode. So we have a brand new runtime. It's been mostly positive, but there's been a few challenges we've had to address, so it's happy and sad. Our new runtime is called IR. It stands for Internal Representation. As I said, it's a complete replacement of our runtime from 1.7. And we wanted something that had a traditional compiler architecture. We wanted to make sure that if you had ever taken a compiler's course at the university or you read a compiler's book, that you'd recognize words like control flow graph or basic block. Or if you looked at a compiler pass and we did an optimization, you'd see meet over all paths and know what that meant without actually having to learn JRuby's source code. So in JRuby 1.7 and earlier, we would go and parse Ruby and then generate an abstract syntax tree, and then we'd have an interpreter that would just bounce around in the tree, or we'd have our JIT, which would just bounce around in the tree and generate Java bytecode. But now, in 9000, we generate virtual machine instructions, and these machine instructions represent Ruby semantics, and we made these up. So the first benefit for me is I find it a lot more readable than what we had before. Here is our instructions displayed in a tool called Ideal Graph Visualizer. You can see towards the center of the page, we have BNE instruction for branch not equals, and then we have the two paths. So I can see the flow, I can trace through the instructions and seeing what it's doing. Off on the right side, I have a control flow graph. We just started integrating with this tool. The really cool thing that's coming down the road is every time we run a compiler pass, we potentially change these instructions. The tool allows you to specify what things have changed, and then you can do a graphical diff of what's changed. So it's going to help us be able to understand how our optimizations are affecting code easier. So it should make debugging a lot easier. Okay, so Java became famous with an acronym, write once, run anywhere. So I want to make JRuby famous with acronyms. Fix once, run anywhere. In JRuby 1.7, if there was a bug with Ruby semantics, we basically had to fix code in two places. We'd have to fix it once in our interpreter and once in our JIT. Now in JRuby 9000, we pretty much just have to fix the instructions that we emit, and then it works just in the interpreter and the JIT with no other work. And here's just an example. When we added the Ruby 2.3 feature, frozen string literal pragma, we had to update the parser to support this, but on the IR side of things, all we had to do is add that top if statement. We just check to see if the node's frozen, and we just create a frozen string operand instead of a string literal operand, and the feature was just done. So that was pretty cool. Any guess on the O? No, I'll just tell you. Optimize once, run anywhere. This is sort of a continuation of the last point. Any compiler passes or optimizations that we make will work in both the interpreter and the JIT. So a lot of times the optimizations don't actually benefit the interpreter, but it's a great property to have in a runtime, because in the past, when we do an optimization, we generate Java bytecode, and Java bytecode's very low, so it would kind of go below the fold of good Java tooling, and it was difficult to figure out what was wrong. Now in JRuby 9000 with IR, we mostly just have to look at the instructions that we emit, and that's usually enough to figure it out. But if it's not, then we run JRuby in pure interpreted mode, and then we just start a debugger in our IDE, and we can usually figure out things pretty simply. All right, no one's going to figure this out. And it's a joke. Just giving a little forecasting there. Startup once, take forever. JRuby is known as not having fast startup. And in JRuby 9000, we still have that problem. So if we look at the pipeline in JRuby 1.7, we had parsed Ruby source code, and we generate the abstract syntax tree that I showed earlier. But then the interpreter would just start executing. So that's what we're competing with in 9000. But you can see in 9000, we have to create these instructions, and then we do a bunch of other stuff. Well, we tried to cut that down. So right after we make our instructions, we made a special interpreter that knows how to walk those instructions without doing any other analysis. However, you'll notice that we're actually doing more work than we were before, and this turns out to be about a 5 to 10% penalty. We knew about this years in advance, so we decided we'd try to fix this another way. When you'd go and read in and parse Ruby source code, we would go and dump its intermediate representation to disk, and then the next time you tried to go and load that source code, if it was there, we just load that and bypass parsing and building and stuff. It's going to win, right? Yeah, it didn't work out so well. Here's some numbers running a simple Rails application, going into console and just exiting right away. On the left is running JRuby with just default arguments. The blue line is just doing the full parse, and the red line is actually loading from persisted data. So you can see that we shaved off a few seconds by doing this method. But the problem here is that if you're doing development time activities with JRuby, you should be passing --dev. If you look on the right side, it's barely faster. So it made this feature not worth it. It's even worse in that we were doing lazy loading. So we'd go and load the entire file. We'd register the methods, but we wouldn't process any of the method bodies. And when you load Rails console, maybe only 20% of the methods are actually executed. So 80% of it wasn't actually getting loaded. And the basic problem is that Ruby source code's very dense information, and our instructions, we're doing a lot more I/O. We haven't fully given up on this idea. Subramanya Sastry, our IR architect, came up with the idea of a binary interpreter. So if we go and change the format in a way that is a little more fixed width, so we can just easily seek across the binary file, we can just execute each instruction we see without instantiating an instruction object and instantiating n operand objects. So it will definitely start executing faster, but it might be a horrendously slow interpreter. So we just have to try it. Our IR persistence work wasn't for naught. In JRuby, we have the ability to compile Ruby to Java class files with our ahead-of-time compilation feature. In JRuby 1.7, if you passed a really, really large Ruby method to be ahead-of-time compiled, sometimes it would fail because we'd generate Java bytecode, and there's a limitation on method sizes that they need to be less than 32K, or it just is too big. And it's a surprisingly difficult problem to go and split bytecode apart. So now in 9000, instead we just dump our persisted data into 32K chunks, and we load that into the interpreter. And then if it's hot enough to JIT, then we JIT it. This is actually the behavior that we want ahead-of-time compiled classes to have. We don't want to compile the world. Trust me, it doesn't help your code run any faster. All right. Interpreter performance is a little bit slower on JRuby 9000 than 1.7. It's one particular use case. If you go and execute a source file and nothing in that file runs long enough to JIT, then you can see that it's running slower. Now you might be thinking, well, that's probably how all my specs run. I just run each file once, but usually you're interacting with your library and you're calling stuff in your library enough for things JIT. Once things JIT, then that becomes the majority of your performance footprint, and having a slightly slower interpreter doesn't really affect you. We do have one user where this is a significant problem, though. The reason why this is a little bit slower is we're emulating a virtual machine, we're advancing a program counter, we're decoding operands. It's a register-based machine, so we're doing lots of load stores into our registers, and so we're indirecting accesses to objects through a primitive array in Java, and that's just something that we didn't have to do in the last interpreter, so it just adds up. So another decision that we made that in retrospect ended up being a mistake is we designed everything to be mutable in IR, because we figured it would be faster just to go and change something in place than it would be to make 2 copies of something. So let's look at an example. Here's a method simplify operands in our base instruction class. So let's think about a compiler pass where it figures out that a local variable is always going to be the fixed num 3. So once it figures this out, it calls simplify operands on every instruction and then replaces any occurrence of that local variable with the fixed num 3, or I should say integer now. Ruby 2.4 support's coming. But now if you go back and think about our IR pipeline and pretend we just had 1 copy of our instructions, we can't be walking our interpreter and executing that instruction while we're modifying it in place. So we ended up with 2 copies of everything anyways. So we've been slowly converting everything to be more immutable, and this has ended up having a really good secondary effect that we're able to share a lot of instances across our different compiled units. So there's some instructions that are used in every single block and method, and we can replace that with like a single instance of an object. So we're getting some fairly significant memory savings by changing to be immutable. So IR has been really, really positive for me. I really enjoy working on IR a lot more than our last code base. I think it's easier to get traction on a problem and figure out what's wrong. I showed some of the tooling earlier that is going to show that that potential is going to improve a bit more. Adding new features has been really, really easy, and we're not doing it in 2 places. That's a huge, huge win. Of the negatives we have, the interpreter performance being a little bit slower is mitigated by our JIT. whenever the JIT comes into play, it makes it less important, but our JIT keeps getting faster and faster in JRuby 9000, so we're starting to pass JRuby 1.7 now, and that's going to continue to improve and then make that even less of an issue. Startup time is, it's bad, but we do have some other plans in play. I said the binary interpreter for loading persisted IR. I hope that gives a significant gain, but we've been talking to Oracle, and they have a product that allows you to compile your Java to an executable, and we got to play with a very, very, very early experimental version of that, and that cut our startup time in half, and it didn't behave very well with our parser and how it was written, so we think that that product shows a lot of promise, so we're always trying to improve this. We recognize that it's our largest issue for our project. Mutability, we made a design mistake. Everyone makes design mistakes in software, and we're correcting that. But IR has been great. I would say overall, 9000 has been our smoothest significant release, where we've had to switch branches. I said we hadn't switched major releases in 7 years, but we had 1.0 was the major release, and then we had a 1.1, 1.2, 1.3, all the way to 1.7. We all know how to count, but each one of those point releases were sort of like a major release as well, and each one of those had bumps. And by comparison with all the things we changed in 9000, I think it's went smoother than all of those point releases. So I've been really happy in how it's turned out. And that's all I have. Thank you.
Thank you very much, Thomas. Do you have any question for him? To him? Oh.
Except him.
I'm curious about this executable compiler thing that you got to play with.
Yeah.
Could you talk a little bit more about that? And if it's available at all?
It's something that they've developed, and it's not open or public, but they recognize that we had an issue and that we're a really good use case because we do have a significant startup time issue. So we're cooperating to actually see what they can do with the tool itself. And they say we can use it. I hope that ends up being true. It might be worth us paying for it if we can't, if it gets the gains that we want, but there's not really a lot to be said.
Anything else? Oh, okay.
翻訳お願いします。CRuby との互換性を保つのに何か頑張っていることとか苦労していることとかいくつかあれば教えてほしいなと思います。
わかりません。
ヒロ、手伝ってください。He has questions about CRuby.
What do you work on in order to keep the up-to-date compatibility with CRuby?
It's a good question. Mostly for the new version of Ruby, we've been running masters or head copy of CRuby's unit tests. I'm hoping that Ruby/spec project will be more proactive on 2.4 features. I have seen that some stuff has been added, so both of those. But We also look at commit logs for features to see what changed. For working on stuff like our parser is basically a port of MRI's parsers, so it's mostly just seeing what changed. So between the tests and looking at commits, it's usually pretty easy. And that's why it doesn't take us as long to gain that compatibility, because we learn from what JRuby does.
Any question more?
How truffle relates to IR?
To where?
IR.
Oh, IR. How difficult was it to
Different.
develop IR? Yeah. Oh, it's a great question. How difficult was it to translate to IR? Subramanya Sastry approached us 5 years ago, or maybe 6 years ago, and he got his PhD in writing an optimizing compiler in Java. And a lot of the work associated with what went into IR was his PhD work. So he translated most of the ideas from that work into making Ruby. Now, one of the big problems with that is Java is more, it's easier in Java to do certain optimizations. So Sabu, as we call him Sabu, he learned a lot about how difficult it is to optimize Ruby. So the original IR design has changed and evolved a lot because the optimizations that we do are very, very conservative compared to what he was able to do when he wrote his original compiler for Java. But it took 4 or 5 years, not full time, but it took a very long time to develop.
Okay. Do you have any question more? So, thank you again, Thomas さん。ありがとうございました。